Okay, so the purpose of this video is to show you that it's possible to have an Arduino Uno. This is the SparkFun board, but an Arduino Uno drive two separate PWM duty cycles at the same frequency. I think you can set different frequencies too. So this potentiometer in the back controls this back LED brightness using a PWM signal, and the one in the front controls the front LED brightness, obviously. And you can see over here I have the most set up to be running at the same frequency, 20 kHz, and this is the front LED adjusting while the duty cycle of the second LED is constant, and this is the second LED adjusting while the duty cycle of the first LED is constant. So yeah. So now I'm just going to walk you through like the code that you can use to find this. So I found this, there's an Arduino library called the PWMFrequency library. It's pretty famous now. But yeah, so if you just go to Google and you type in Arduino PWM frequency library, it'll bring you to this page on the Arduino website, or Arduino forum, by this guy, Runner-Up. He made a whole frequency library with functions and stuff where you can select whatever frequency you want to run your PWM signal at. So you just come down at the end of his first post, and he has like a link where you can go to download the library. So then you just install that in your Arduino library folder, and in your Arduino script you just include that library that you download from the link. It'll be called pwm.h, and then in the link on the Arduino page he has outlined like some methods, or I guess functions and initialization functions of how to set up this, like how to use his PWM frequency library. And basically what it is you'll define the pins that you want to set your PWM output on, and you'll define a frequency that you want for your PWM, like frequency obviously. And then in the setup loop there's this method called InitTimersSafe, and what this does is it sets up the timers, like the clocks basically, within the Arduino Uno, so that you can use them to like have a configurable, like customizable PWM frequency to operate at. And you'll use these methods, which you can find by searching for the PWM frequency library, like on Google. It'll be on that Arduino page, and use this to set up the frequencies, set the frequency for your PWM pins. So the trick to setting these up is to choose, so the Arduino has 3 different timers, like 3 different clocks you can use to generate the PWM cycle. The trick is not to use timer 0, which is like the one that Arduino uses for like its pre-built functions, like the millis function, which you can use like to count for seconds, like say you want to turn a light off and on like every second or something. If you want to use that function, do not use timer 0. You need to use PWM pins that correspond to timer 1, which are I think 9 and 10, and timer 2, which are pins 11 and 3. So when you set up this PWM, you want to use pins that correspond to timer 1 and timer 2 if you want to be able to use the pre-built like Arduino functions for like they count seconds and like other functions that are pre-built that rely on like timekeeping. So don't mess with timer 0, which is like PWM pins like 5 and 6, I think. So yeah, you just set it up, and if the setup's successful, they give you this like in the example code they give you this like success if statement. So like if the initialization for the PWM pins was successful, it'll light up that pre-built LED pin 13 on the board. And then in your loop, I mean this is just like to test it out, you can I just have those two potentiometers there, the front one for the front LED, the back one for the back LED obviously, and yeah, I just read an analog signal in off of those and set the PWM duty cycle based upon the value that was read in. So, and also the method, now for using, if you use the PWM library, usually it's analogRead to set the PWM duty cycle, but in this case, for this library, the method is called, or function is called pwmWrite. And then you just put the pin, your PWM pin, and then this, like whatever 8-bit value you want to set the duty cycle to be. So duty cycles are always 8 bits, but like the analog rate is 16, so you have to divide by 4 or whatever to get that 0 to 255 range. So and yeah, so using this library, I'll just give you a quick example. I'll change the frequency to be like 5,000, just to show you, give you an example of how it's like completely customizable. And the code's uploading, and you can see, boom, frequency on the oscilloscope. It didn't change the time scaling, but with the slower frequency, you can see that the period got longer. And as I adjust one, you can see the other one stays completely constant, the duty cycle of it. And here's another example down here. It's like the visual demonstration. Boom, super useful. So I'll put this up